So good afternoon, folks. My name is Eric Fulmer, and this is a tutorial about decorators. It had its genesis in one of the many times that I was working on something. I was trying to get something or other to work, and the end result was that I got very mad at a computer. It didn't end poorly, but it ended with a lot of frustration. And it turns out this is kind of a common stumbling block for a lot of people. Some of the decorator tutorials, they use syntax, which is straightforward, but it looks really weird in the way that it is presented. So I'm trying to show it at a slightly different angle. Hopefully it's a beginner, intermediate level. If you understand how a function is defined, you should be able to follow along. And so main goals here are you understand what a decorator is, and you understand how you would use it, when to use it, what purpose does it serve. And because I say a lot of really inane and stupid things, if you leave this room without being annoyed by something I've said, then I have done something very wrong. Do keep that in mind. That's not a major theme, but it's important. You know, the whole four quadrants, major, minor, important, unimportant, like going to the dentist. That's the idea. Anyway, so we're going to start with just what is a function. Decorators, it's basically an operation that you perform on functions. So you have a function, if you have to define a fizzbuzz, because it's the basic contrived interview, you're going to start with def fizzbuzz, but that's not really all it is. We also have lambdas, which are a one-line function, which people use a lot for things like map, filter, reduce, some things in the functools module. So those are that, but what does a function do? Let's be sort of philosophical and think, what's the purpose of a function? Why do we have a function? And the general idea is that a function does something. It gets some data from somewhere. Maybe you're reading a config file somehow. Maybe you're getting a result of one database query and using that to create another one. Maybe you're reading off of a message queue. But either way, you're getting some data in and you're sending some data back out into the world. A lot of the time, return keyword, but again, you can write something back out to the message queue, insert some more records into a database, write to a file. The idea is input gets changed, maybe rejected based on some logical rules. They could be for business logic. They could be if you're writing mathematical code for like a number theory class. It could be to filter out non-primes, for instance, but take something in, you work on it, and you send what you did out to the world. That's the heart of it. Creating functions is our organizational technique for it. It's pretty simple. We're starting with 101 because we're hopefully going to hit some really weird and funny stuff. So one interesting thing, I'll hop over to the REPL to demonstrate it, but Python goes by the everything is an object protocol. And one thing in Python you'll say is you can literally call the method call on a function because it's an object. Now, so if you wanted to do something like int dot. All right, well, we'll scratch that for now, but if you try it out, you can, instead of actually calling a function with foo parentheses, you can call its dunder call method.
I think you might have just zoomed too much.
Yeah, we could see before you zoomed
Oh.
in real far.
Oh, did I? It was tiny to me. It made sense. You just had to, Made sense if you could see the future and know what I was doing. So, did I? Yeah. Thank you for bearing with me, legit. This is my first talk. So, int call 3, string 3 returns the integer 3. Everything in Python is an object. Your functions are objects. You can go into a lot of different places with this, but we care about the functions now, so we're just going to leave it with functions are a type of object, which means they have attributes and they have methods. The one we usually care about is this call method. So, knowing this, like, what do we do with objects? We can, we create them, we can call them, we can use them with other objects, whether they're components of the other object or they're passed into one of its methods. And whoa, we just went back to functions. So we're just reiterating something here, which is it's another object, and def, foo, blah, 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 is just, it's just a way to create a new name. And you can, if you have a function name, foo, you can change that name. You can rebind it to a different name. Like if we want to do something really dumb, like we can just get rid of the standard built-in string function, which looks really weird, and it actually is really weird because the way that we define functions is different. You can define lambdas like odd is lambda x mod 2 not equal 0. So they're just another type of object. Whenever we define functions, whether it's inside of a class as methods, whether it's at the top module level, we're just creating that name. That's what it does. So we can define functions inside of other functions, which looks kind of funky, and it is kind of funky because you may think, what is the point of that? And the point of that, we're going to figure out what the point of that is. Now, if you've done any like Lisp or functional programming, or you've studied higher math, you probably know about the idea of apologies, but you know the idea of a higher order function, which is a function that works on functions. If you have integers, booleans, dictionaries, database records, those are just objects. But functions that work with other functions, they have that critical difference that you can call them. It's just an object that you can call. So you can send a function into another function and use it that way. If you've seen map or filter or a lot of things in the functools or itertools library, this is a common technique. And you can also return functions from other functions. Not to read off the slides, but the derivative and integral from calculus, they transform other functions. And so decorators are where we take a function in and we return another function. And in between, we do some special stuff before we call the function. And because we've used the word function a lot, we'll break that down by going through an example. Right here, we have a fancier hello world where you can choose both your salutation and your target. So we'll do this, and we'll see something happen. We're allowing them to create it without giving a greeting, default to hello. And now we have the function inside the function. Remember, we're just creating another object inside a function. It's like creating a new list or a new tuple. it looks different, but in the end, it's the same thing, and the repetition of that will help make you really get it and become a function genius. That's the goal. If I have not made you all function geniuses, then I made a big mistake. I've done something very wrong. And so we're going through this pretty briskly, but you might have noticed something here, which is after greeting gets called, greet falls out of scope. So, and let's see what happens. Does that like create some sort of name error when we run this? You know the answer is no, but. Oh, yeah. So we do have a name error, just for different reasons. So.
You're off the screen.
Oh, control. Oh, yeah.
Oh, yeah. There you go.
Yeah, so. Yeah, so this is, I'm gonna have to just hit enter a bunch of times. I did not anticipate this. But you see, high is still in scope, even though you would have thought the greeting would have fallen out of scope after that call up greet ended, but it doesn't. And if you just do it with the default hello, same thing happens. Greeting hello. So one interesting things about functions is that they know when you've defined a special variable that gets used inside of an inner function, there's actually an attribute for it. I'm going to try and remember the name for it and print it out.
Should be able to type in Control L
Yeah.
there if you want to.
See, is it its name?
Control L.
Oh, whoops, my bad. Zoom out, okay.
You're above the screen. There you go.
Oh, so if you look at line 12, we have that code special variable of our function object. That CO cell bars attribute actually stores the variables that need to be kept around because they're used inside the inner functions. So that's one of the most useful things about this is that you can set up your decorator so that it keeps useful variables around even after the outer function goes away. So our salutation is always there. We don't have to worry about that disappearing even after the run of greeter ends, which is pretty cool. So the general sort of design pattern of decorators is that you have a function which takes another function, it does some extra stuff, and it calls the input function. Apologies. You could write a decorator that does not run its input function, but that wouldn't have much of a use. So depending on what the actual decorator does, what the work that's being done is different. And also, if you look at the second example, we have a syntax to create a decorator. This func equals decorator of func, but I really hate the way that looks. I really hate that because we're like reassigning a function to some other function that we call with the same name. It looks really strange. It's very confusing. I don't like looking at it. And like you read the function definition and then there's some really important information about its usage after that. That makes no sense. I really think that's garbage. So the Python, do we have any Python core developers in here? Some very smart core developers came up with a PEP to create a special syntax for decorators, where you put, well, I'll just show you. Well, no, never mind that one. It's a later slide. But if you use this special at notation to add, it's basically I read it as add, but if you, so you can do at decorator name and then define, is it again? Oh, that's not good.
There you go.
Yeah. Equals. This doesn't actually do anything, but it demonstrates the syntax. Basically, you put at decorator on the line right before the function. And it does the exact same thing as this example right here. The one which I just said, and I sincerely believe sucks. So we can kind of come up with an analogy for this with classes, where you have inheritance, which is where you take a lot of the existing functionality and you have existing methods that you use elsewhere. And a lot of times you're going to call, like if you inherit from another class and that class overrides under init, you're going to call the parent class under init with super, which is basically what decorators are doing. It's not a perfect analogy, but if you're looking for one, a pretty strong analogy is to liken them to sort of inheritance for functions. Oh. So there was a PEP that gives you this special syntax. And what property is, it's basically a special decorator which allows you to create, like, override setters and getters. If you come from Java, it's like the setX and getX methods you'll define for most of your classes. We have a special separate underscore countdown that does stuff, and if somebody tries to set it, we don't like their value, we reject it with an exception. And I like to use that at notation to sort of just think of add functionality to this function. Property is just, we're going to add special get set behavior. So this is an example that I created, actually. And it's kind of trivial. What it does is you have a function, you decorate it with this, and you call it in with its arguments in reverse order. So if you were trying to do something like this print foo of AB, it wouldn't give you AB, it would give you BA. Or if you tried to use a more classic example, if you tried to do hello, hello and world, it would give you world hello, which we'll come back to. But here's a more real example. If you've used a Flask, the web framework, it has this route method. And this is literally the source code for route, which we'll use as a decorator in Flask if you want a function to run when somebody queries you for a specific URL. And you can look at it really quickly because it's only a couple of lines, but the key one is we add this add URL rule where Flask hooks your function up to its internal mechanisms to run it when it gets the right request. So it's very useful, very powerful. And Flask gets this with, what's that, 6 lines of code? This is literally the entire definition of route. It's really useful. And there's, of course, a lot of others. This is literally the Flask front page example, but that's how easy it is to use. It's another example of that at notation, which looks a lot simpler. It shows you how exactly this function gets used. So there's some more examples here. There's tons. There's a context manager decorator, which makes whatever function you decorate with it, a context manager, static method and class method let you do Java-esque methods that are either attached to the class itself or just inside the class but don't work with an instance of it. Partial lets you save some of the arguments you gave to a function and pass the rest in later. There's a lot of cool ones. And now you think, okay, I know what this is, I know what it does, but how do I use it? We're sort of revisiting our inheritance analogy, but what a decorator does is, again, it adds behavior to functions.